Hello and welcome everybody, and thank you for joining the Sitecore User Group France today. And a special thanks to the speakers and to the organizers. I would like to introduce quickly. So we have Hugo, who is a head of product at Perfection, and he's doing his magic at the moment actually to have this amazing live stream in YouTube. We have Vinay Kumar, it's a global Sitecore architect at Baltec, and myself, I'm also working together with Ram at the same role in Baltec. So this is the third event in a year, and we are really happy to see how the French community is growing. So we really encourage you to subscribe to the YouTube channel, to follow us on Twitter, on LinkedIn, and register to the meetup as well. And for the people joining from France, stay tuned because we are already organizing in-person event in September. So after the summer break, so we not only share Sitecore, but also we have some drinks and we have some fun together. I hope you all enjoy the sessions. Before that, I would like to share some quick notes. First, all your questions, please write it down to the YouTube chat. We will do our best to answer to those. So we will give in like 5 minutes at the end of each session to answer as many as possible. And as a reminder, we are also recording the session, so we'll be available as soon as we finish with the streaming. And that's it. So Guido, if you are ready, yeah, floor is yours.
All right. Well, first of all, thanks for having me. In this session, I want to share some of my experience with Sitecore on Kubernetes and share some of the learnings, or rather explain how I was able to get started with hosting Sitecore on Kubernetes. First off, a quick introduction about myself. My name is Guido van Tricht. I work at Baltec out of the Netherlands as a Sitecore technical director. I've 10 or so years with Sitecore, and in the past 3 years I've been working on various projects with which we have hosted on Kubernetes. So for the agenda, what I first want to do is give an introduction to what Kubernetes is, explain some of the basic concepts of Kubernetes and what some terminology means that you really need to understand before you even get started. Then how to define a Sitecore deployment for Kubernetes, and end off with some helpful or a mention to some useful tools that you will probably want to use while working with Kubernetes. So first off, the introduction. And when I started with Kubernetes, or rather container development, what helped me understand what it really means and how it works was to understand where it came from, what the history of hosting an application on the internet, not the cloud per se, how that evolved over the past, well, pretty much a couple of years, if you think about it. So going back to like, let's say 10 years ago, a lot of the things we were hosting were still on-premise hosted, meaning you'd get access to a physical server, which was either placed in one of your locations, offices, or you were renting it from a third party. And when you got access to that machine, you would have to, first of all, install the operating system, and then on top of that, any application that you wanted to run on that server. The problem with that is that, one, everything was manual. You'd have to do it over and over again for every single machine that you were spinning up. And second, every application that you hosted on the server was using each other's resources and could get mixed up in that and raise for resource conditions. After that, we moved to a more virtual machine setup, right? Still, you would have a physical machine somewhere, whether you have access to it or not. That is where the cloud came into play as well. You would get only access to a single virtual machine, but in the end, it's still running on some physical server. Within that virtual machine, again, you would have to install your operating system or choose it. And on top of that, manually install any application you wanted to host on that, whether it was SQL, IIS, or any other application that was running. The problem with that is that, as described in the diagram, every machine needed its own operating system. And as we know, especially with Windows, operating systems are heavy. Having a single physical machine hosting 3 different operating systems takes up quite a lot of resources alone. The next step in this process is where we're at now, and that is containers. Containers are very similar to what a VM is, but they have a so-called relaxed isolation, meaning that they can reuse an existing operating system of the underlying machine, whether it's a physical or virtual machine, it doesn't matter. And this way, you get rid of all the operating systems that you needed to host. Instead, you just need one, and that saves a lot of resources. Next to that, these containers are built based on images, which are a step-by-step or a templated set of instructions on which define what kind of software to install and how to run that. Meaning that you no longer had to manually go into the machine and set up any software that you needed to run. Now it's all automated and built into an image. And the added benefit of that is that these containers are then portable. So however you want to run it, that is the state that will be matched across all your environments. Whether you host the container on your local laptop or machine, or whether it's in production, it acts the exact same way. Now, in order to get these containers to work, you need those images, like I mentioned. And most of us will probably know Docker as one of the things that they might be using on the local development, which is coming more and more usual to see. And Docker is built on, or has this concept of Docker files, which in the file you'll define which line by line, which environment, or which command to run in order to get this container created. Sitecore provides some base images of that, and Docker then allows us to layer image over image over image, allowing us to basically extend what Sitecore is already providing us. So the Sitecore base images contain everything we need to host a clean CM or CD, for example. And on top of that, we can add our own version or layer to deploy any custom code. Eventually, in order to host this somewhere else than your own, even in your own lab machine, you build the image and push it to a registry. And from that registry is basically a storage where anyone, if they have access, can download the image and run it inside a container. So now imagine that you have a Sitecore XP environment. You're gonna host everything in containers instead of doing it in a virtual machine or in PaaS. That requires quite a lot of containers to be hosted and maintained. Not just the set of containers that you need, but also including the scaling. So scaling out requires multiple containers to be running of the same type. If you look at this more regular environment based on XP and headless, in this case on top of Sitecore Managed Cloud, that gives you 34 different images, 39 deployments, which end up in 107 containers. This is just a single environment, let alone having your entire street of 3 or 4 different environments and your local one to manage. You don't want to be managing all of this on your own. So that's where Kubernetes comes into play. Kubernetes is a container orchestration software or hosting. and comes with a lot of functionalities which help you orchestrate and maintain your environment. It allows load balancing, storage orchestration, automated deployments, and all deployment processes that you would want. Based on the configuration you give it, it will try to self-heal your applications if something ends up breaking, and it contains secret and configuration management. So now we'll dive a little deeper into some of the concepts and parts that Kubernetes consists of, and what we need to understand to host an application in there, because it's quite a complex system, really, that we're trying to use as a basis for our hosted environments. So some of the terms that you'll see more often is these couple, which is the baseline of your hosting. First off, a Kubernetes cluster, which is another name for your environment. The Kubernetes cluster is everything that consists within Kubernetes and is capable of hosting all the deployments or applications that you want it to host. Part of each cluster is a set of components, APIs, and schedulers, which Kubernetes itself will control and use to manage the state of your applications. So everything is API based. That means you could even send an API request with Postman, for example, to do something. But Kubernetes made it easier with other tooling like the scheduler, which will allow you to just tell it what to do, and the Kubernetes itself will then start deploying things. With a cluster alone, you're nowhere, though. The cluster itself does not host anything. For that, it needs nodes, which you can actually compare again to virtual machines which have Kubernetes installed. And these nodes are then used by Kubernetes to host applications on or containers. And the last one in this list is a pod, which I want to mention, and I'll dive in a little deeper. But a pod is basically a wrapper around your containers. So if we flip it around and dive in a little deeper as to what these things mean, then a pod is the smallest unit of work in each Kubernetes platform. It can consist of one or more, but usually one, container that's hosted within a pod. And the benefit of having it in a pod, or what it does, is that it automatically allows you to share resources and networking within the pod. So any containers that are running in it can share storage, and it will attach to the virtual network that Kubernetes has created and assign an IP address to it. You will probably never know this IP address, so you can look it up, but later on we'll see what you need to do in order to find your application. If you zoom out, then we get to the node. And again, a node is where all your applications are running on. Kubernetes will decide which applications or which pods and containers to run on which node. It will evenly spread it out. But a node can therefore consist of multiple different pods. And each pod will then get its own IP address linked to the virtual network of Kubernetes, etc., etc. And then zooming out further is the full cluster. So here's an example of what that could look like. In this example, there are two different node pools, meaning groups of nodes, one for Windows, one for Linux. And on top of that, there are 8 pods hosted. Kubernetes has then gone, or you tell Kubernetes which containers and pods to host. Kubernetes will then evenly distribute those across the available nodes. But sometimes that means that it's not actually even. Like, for example, in this Linux node pool, there are 2 pods, probably because there were, in this case, 3 pods that needed to be hosted on Linux, but only 2 nodes available. Kubernetes will, however, consider all your resources, available resources, and what is reserved for each application. So it will try to evenly split it as much as possible. The application, if you think about how to use this, then it's a little different compared to PaaS. When you look at PaaS, then you are the one deploying a package to a web app in Azure, and that's going to be run. You define where your package will be deployed to and how much resources it has, how it's scaled, etc., etc. With Kubernetes, it's somewhat the other way around. You just tell it, these images I want to host, and Kubernetes will do the rest. So first of all, you need to have those images built and pushed to a registry. And then you can tell Kubernetes what to do, how to host your applications and where to find the images. And you can do that with 2 ways, either separate YAML files or Helm charts. And Helm charts in this case are templated out templates for more structured deployments of multi-container setups. And I've scratched it out here because we don't actually have officially supported Helm charts for Sitecore. So what we will be using is those YAML files. And those files describe the desired state. Again, that includes which container or image to host, how much resources it should have, the environment variables, and how many instances should be running for this container or application. And Kubernetes will then continuously monitor and control status as best effort on how to do that. So if we look at defining a Sitecore deployment, then there are 2 parts to this. Sitecore is providing a baseline for us to use, and there are 2 parts to it. One, again, the images. Sitecore provides those base images which we can use, but those will need to be customized with your custom code. When you build those images, try to think of how you can reuse specific layers that you're building with your custom code. For example, your solution, your Visual Studio solution, is usually deployed to both CM and CD, likewise in a Docker setup. Try and build layers that make sense and can be reused across different images. That will help you control how long it takes to build, because building images can take quite some time, especially if you're doing a lot of images like an XP setup. And Windows is obviously also a lot slower than Linux images. I'm not going to go into very much detail of the Docker and images setup, but rather focus on the Kubernetes part of this. And Sitecore also offers us a base topology of Kubernetes manifests. And there's a link to GitHub. Those are all stored there. And it contains a set of examples on how to do that. So I have it open here in the Sitecore container deployment repository. And there are in the K8s/SXP folder, for example, we have the different 10.3 setups for XM and XP. And these folders contain everything you need to deploy Sitecore to Kubernetes. Separated in certain folders, but for example, a content delivery YAML. We'll go into what this means later on as well, but there's a baseline which you can use as an example, and if you'd like. Next to the baseline for Sitecore itself, there are also options or examples for different modules, how to install that, like Experience Edge, Horizon, Publishing Service, etc. So do take a look at these examples when you get started, which might help. Now let's take a look to see what these manifests are. As you just saw, the CD manifest itself, I can open it again, for XP, is a file of 206 lines. That's quite a lot. So let's see what this means, because every single manifest is conform a specific structure. On the very top, it defines what kind of resource should be hosted, or what kind of resource this file is describing. In this case, it's a deployment, and that means that it's deploying a set, one or multiple containers with a specific image, and this is what you'll be using to deploy your applications like CM, CD, etc. Secondly, you'll see that there's metadata, a name and some labels which you can define yourself. And this is what will be used to tell your resources apart. As you recall, every pod gets an IP address within the virtual network, but you don't know that until it's been deployed. But you do need to set up some network routing, etc., within your other configurations. And you do that by pointing your routing, and we can see an example later on as well, by using these labels as an example. The third section is the spec, meaning the specification of the resource. In this case, again, with a deployment, there is a selector, replicas, and templates nodes, which in the end define what this container should look like, or this pod. So on line 19, it dictates what image to use. From 22, it shows all the environment variables and links off to maybe configurations, but that's all the environment variables that you'd need. Line 8, down here, the replicas, so how many of these should be used. And which ports to open on line 20, 21, and further down, which is not in a screenshot, you will see how much resources it has gotten from the Kubernetes or from the node, how much is being reserved for this application, as well as what health checks, health probes to use. So what URLs to call to see if Sitecore is still running properly. So this is an example of one kind of resource, but there are many, many more. You can even create your own types of resources in Kubernetes. But if you look at a very simple diagram and example, the bare minimum that you would need to expose an application to the outside world, then you'd end up with 4 or 5 different resources. So in the diagram, you are the client, you're in your browser or whatever tool, and you want to make a request to Kubernetes. First thing you need, or it passes through, is an ingress. And that is basically a definition of what HTTP or domains to listen for. It might offer different other configurations like SSL termination with certificates. I mean, load balancing and other things are possible in there. Within that ingress, there's specific routing rules, meaning based on the path or domain, you can route a request to different services. Now, for a CD or CM, that might just be one rule. Everything should go to the same service. And a service is attached to a deployment to expose one of the ports to the virtual network or to the internet. So by default, no matter what you deploy, no matter which port you might have opened in your IIS in the image, those do not get opened up unless you define that. And this service then points to a deployment. As you can see, deployment itself is not something that's actually being used or shown in the diagram. Rather, that ends up being one or more pods. And this deployment then includes, you still point the service to a deployment or through the metadata to make sure that it reaches the correct pods. This includes load balancing as well. So if you have multiple pods in there, then Kubernetes will decide based on how much traffic there is, which pod to direct traffic or request to. And next to that, it will include some self-healing, what I discussed earlier, based on the health probes that you have. Two other notable mentions are config maps and secrets, which are two ways of storing configuration in a Kubernetes cluster. The config map is a key value pair, which you can define in a text file or some of some sorts, and deploy and use through the environment variables in your deployment or any other part of the resources or YAML files where you can use the config maps as a source for configuration. That's used for any non-confidential data. Secrets, however, are meant still, they are key value pairs, but they are tokenized and meant for more sensitive data usage, so like passwords, tokens, or other things you might not want to have stored as plain text. And again, these things can also be used through environment variables. So they're very similar in that it's just the way how they're stored, really. If you think about how this ends up being, how much files or how much descriptions you need to create, then that is quite a lot. We just saw the folder structure. There are quite some files in there. Normally, with Kubernetes out of the box, you would need all of that into one file. You don't want to be creating a file of thousands and thousands of lines of YAML configuration. Even though it's possible, that's not really maintainable. So one thing you can use instead is something called customize. And again, as Kubernetes is that infrastructure as code, or based on the infrastructure as code principle, these config files will dictate how your application is deployed. But it's not just one application, it's those 107 containers in the end. So by splitting your deployments into multiple files, you can control and maintain your applications more easily. And with Customize, you can then combine all those files into a single output or file and deploy that file through to Kubernetes. On top of that, it also allows patching, which is useful for patching specifics for different hosting environments. Like in the image, there's a patch for staging and for production, which just make small changes to what the base had suggested it should be. If you then look at what it takes to create such a setup, like the one Sitecore has done, then you could say there are 3 steps involved in doing so. One is creating a folder structure. First of all, you need to create a folder structure to make sure that you have a separate setup for the base manifest and create a separate folders for environment overrides or different overrides used by Kubernetes to make up what you want to deploy. You will want to create a structure where you define the differences or set it up in a way that makes sense for you. What I like to do is set it up with or based on the type of resource that's being deployed or what it's used for. But you might also consider doing it on the type of application, whether it's a microservice, a rendering host, a Sitecore. No, it doesn't really matter how you do it as long as it makes sense to you. Secondly, you then create a base manifest. Anything that's reusable across all your environments, you will want to have in the base manifest because you just want that to be defined only once. This can include any services and ingress that are the same, the basis of all your applications without how much or how many instances or resources it can use, for example, so the scaling part of it, but also something I haven't touched upon earlier, jobs, which is a different type of deployment or it's also deploying a container, but has a different lifetime. I might show it later on as well because I'm going really fast. And last part is then, of course, to create the overlays. These overlays is where you then start defining your resources, the sizing of each application, differences between the configuration, etc., etc. So let's try and do that together. I have set up just an empty folder structure in here. We reorganize some screens. So the first thing that we said we would do is create this base folder structure. Again, first thing you do is create a folder for your base next to what will eventually become your overrides. Now within this base, we start defining our manifests. Again, I like to do it based on the type of resource that's being deployed to Kubernetes. So I like to create ingress folders, maybe the volumes, so shared volumes for that are being shared between your environments, applications. And then a folder for any services, so applications that are being exposed to the outside network. Within each of these, you can then start creating your manifests. So let's take YAML, content delivery as an example. I'm just going to copy over one of the examples. And this consists or contains everything I need to host a content delivery. So again, in the deployment, I have a lot of things in here. There's the definition of what this container should look like, which ports might be opened, all the environment variables, linking off to secrets, liveness starter probes. So those are the health probes, which Kubernetes uses to determine whether it should be added to the load balancer or whether it's healthy. So these two endpoints, health /live and /ready, are out of the box with Sitecore and can be used and extended with your custom health checks. Then any volumes that might be shared. So Sitecore XP needs the submit queue, for example, and then the basis for resources that you might need or want. As you can see in this case, it's a little different compared to PaaS, where you're giving your application as much as possible based on the tier that your application or web app has. In Kubernetes, you define a request and limits, meaning the request is the minimum that it needs, and that will be reserved for this application from your node. And the limits is as much as it can use at the same time. This will be used when deploying it. Check, does it even fit on one of the nodes that exists? and this can overrun and influence other applications on that node as well. So be careful with not just giving it the highest limit as possible. It will influence other pods and containers that are running on the same node. As you saw at the top, I have included the service here as well. So this is what a service resource looks like. And because it's so small, and it's only related to the deployment itself, I like to combine it in the same file, and many do. And as you can see, this uses a selector. Instead of selecting a specific IP address of the virtual network, which we don't know at this stage, we're using the selector based on a label called app, and the value should be CD. So that links off to the deployment where the labels app is set to CD. If you then combine or add the CM as another example, then you'll see it's pretty much the same thing, same setup, but in this case, we're adding a selector for app should be CM, and the same thing is defined down here. Now, this is not enough for Kubernetes or Kustomize to combine all your files. It needs customization files. And a customization file is, a file used by Kustomize, which defines how to merge your different files together. And you need one either within all your folders, or depending on how you want to structure it, it's best to do this folder by folder. So creating a customization YAML file. And again, this is exact same setup as any other resource, so YAML based. And this is an example of a semi-custom, even though it's from Kubernetes itself. But it's a customization file or a resource. And then you start defining which resources to include. So you can, in this case, the resources CM and CD will be included into the customization process. If I run this process, customize build, then the customize CLI will read out this file, see, okay, I have two resources defined, and it combines those into one output, even sorting it based on the type of resource. So it first sees the service CD, service CM, and then the two deployments. And you can output this as a separate file and then deploy it. Another handy feature that you can do in here is change the image definition. So as you can see in the CD setup or config, we're referencing an image called Sitecore XP1 CD. This is not gonna work because this is not a valid reference to an image. Instead, what we do is within the customization config, define an images node where we can override those keywords and names and specify a new one. And this is more easy to override in your CI/CD process when you create different versions and tags of your images and then replace it with commands in the file and before building your full customization. Now, that's what we need for a single folder. But we want to create a single base customize file. Again, what we do is create a similar setup. We have within the base folder a customization file. Again, defining the type, same thing as the other one. And using the resources node again, you can now define the folders instead of specific files. You can also define specific files in here, but also folders. And when you specify a folder in this case, then we will try and find the customization file and build this included. I'm not gonna finish this one because we're going to the next folder where I have a full setup. If I build this folder as an example, then it will, doesn't fit in the setup or in my console. You'll see that it contains all the deployments for all the XP roles, anything else, and also jobs from the jobs folder. And it's all included in a single output. If we look at what this means for the services here, we have created a full setup of all the XP roles, for example, including XDB, Cortex, and the CMCI, CD, and identity. It's again same thing. You just do specifying somewhat different parameters each time. The customization file in this case is a little larger, defining which for all the files which image to use, and again referencing all of them. Looking at the volumes as an example is where these are linked, because in this case we've used Azure Container Services, so AKS, Kubernetes services. We use Azure files or disks to specify shared volumes for the submit queue, or shared volume, and for the submit queue, same thing. And those are then also registered through a customization. And in the end, all of those folders are being combined. That's your basis, and that will deploy, will work fine, but at least will it work fine? Maybe not so much, because we haven't really defined any routing yet. So the next thing we want to do, this is the part that's reusable across all the environments. So now we want to start creating folders for every environment. So what I do is create an environments folder, and within here you can create folders like development or production, and these can then use files from the base again. First thing you would do is create a customization file again within this folder. And again, specifying what it should use. And in this case, we're going to specify to use the base as one of the resources. Because this contains a customization file, it will build everything based on that and cascade into a single output. Then next up, what we can do is create resource definitions. So what to override, or how much resources to give a content delivery, for example. This is going to be one of those patch files. So what we define is merely what we want to override. And this will break some of the syntax because it thinks it's missing stuff. But again, we're defining the type of resource, like just the one that we want to override. Provide at least the name, so that customized knows which one or part of the file we're going to override. And then within the spec, we can override the things that we want to override. So with replicas, I could say I want 2 in this case. We're going to change the deploy strategy and give the container with the name CD these resources, request and limit resources. So compared to what it was before, I could look that up, which was 1 gig, 1 CPU, 3 gig, and 2 CPU. Then it's now going to 3 gigabytes of memory and 1.35 CPU. So we're scaling some semi down. At least this is an example of how you can change based on an environment. To override those things, we need to update the customization again with, in this case, a patches node, which defines a patch file pointing to the CD YAML, so that customize knows which what to do with this file, not just treat it as a resource, but also treat it as an, oh, sorry, I want to see how much time I had left. To know what to do with it. Another thing we can do, and that's what I mentioned before as well, is create a config map. And these can be generated based on a properties file. And a properties file is just a key value pair, like, for example, this one, where we will create a key value set of, these are the settings. So the host name to be used by CM and CD, and an environment variable for the ASP.NET Core for a rendering host setup, for example. And these are important, these two, because this is what will link CM to CD as to ID, which will be different for each environment. What you then do is create these config maps, or add a config map generator, specify which files to use and what the name should be. Now I actually starting to wonder if I've actually updated the identity here. Yes. Then within your environment variables, instead of giving it the direct value, you reference a config map by giving it the name and the key of the setting that it needs to take. So same for CM, hostname, and identity hostname. Another thing that you can do as an example, let me show one of the ingresses. Create an extra folder in which I want to define a new ingress or override, and that's going to be this one. So this is an example of an ingress resource, again with some metadata. This is metadata that will be used by other applications, in this case, application gateway in Azure, and define some of the settings, how gateway should be integrated and connected with Kubernetes. And this is an example of those routing rules. So if a request comes in for this host name, this ingress will process it. If the path starts with /exact, then we're going to forward it to the service with the name, CD, and the port number. The service on top of this file, that's called CD, and we're using the port that has been opened. Why do this in a override or an environment specific folder is because of some of these values. Your host names are most probably going to be different from environment to environment, so you will probably want to override that again based on it. And what you can do, again, if you have multiple ingress files, you can again use that same approach that we did in the base folder by creating a specific YAML file, which then only starts referencing the ingress files. And within your base or in the upper folder, reference that ingress folder, and that will cascade into a same in a single file. Let's try and see if I made any mistakes. No, I did not. So as you can see at the end, this also includes the ingress, and not sure I can show, probably not, no. The output will have patched the different or the CD setup as well with the different resource definitions. In the end, what it might look like is something like this, where you have the base, same as what we've seen before. You have all your environments, dev, staging, and production, or how many ever you want. And for each, the resources might be different. For production, you would want maybe a different way of updating or deploying your content delivery, give it more resources compared to what we've seen in the development environment, where we care less about the uptime and or the zero downtime deployments and don't have as much resources available. Staging is going to be somewhat different with different host names, etc., etc. And then you might have your secrets files, which again with customize, you can create or generate secrets based on files if you want. There's also ways to integrate it with and synchronize it with Azure Key Vault, which is probably the better solution than using files, because we're still talking about security or keys, passwords, and tokens. But this is one of the approaches which Sitecore is also using in their examples, where your files or these files are being overwritten with the actual values and then created as secrets. Again, key value pairs that can be used in your environment variables. Let's go back to the slides. I have 5 minutes left. Perfect. So that defines, with that, you will have created a setup which can be deployed to Kubernetes. I'm not going to do that because it's costly to host Kubernetes or Sitecore rather on Kubernetes. But what I wanted to end up with some useful tools that might help you monitor and work with Kubernetes and understand what is going on. One of which that I've been using lately more often is K9S. It's terminal-based UI, and it will show you what is actually running in your Kubernetes cluster. So from any application, pods, or deployments that you've deployed, all your secrets can be read out, your config maps, everything that you want to know about your cluster can be read through this application. You can also even edit your definitions straight through this UI, or rather through a text pad that's going to be uploaded then if you want to make manual changes without having to run a deployment or something like that. And this one is open source and free. Link is there at the bottom. A more friendly UI is Lens, but has recently become pay for use. So unless you go into their GitHub and build a previous version where it was still free, the latest versions are paid. And it gives you exactly the same functionalities as K9S, but with a slightly better view, which is not terminal-based. And the last one I mentioned, and this depends on what you want to do or where you're hosting, rather. What we have used so far is AKS on Azure, and AKS, or the Azure portal itself, also offers these kinds of screens, but in a different way in the portal, where you can see everything that's going on in your application or in your cluster, and read, see logs, make changes if necessary, and see the state of every application that's running. It also includes an integration with Azure monitoring if you enable it. So then automatically all your nodes and pods and containers are being monitored by Azure as well, and that gives great benefit when troubleshooting and monitoring your solution. So that's what I wanted to share today. If you have any questions, feel free to reach out on LinkedIn or Twitter. But there are some minutes left. So are there any questions?
Thank you, Guido. It was a really informative session about Sitecore hosted on AKS. Actually, I don't see any question on YouTube chat, but again, feel free to reach out to Guido if you have any question related to this topic.
Thank you, Miguel. I'm Ehsan, and I'm actually working as a Sitecore Expert Director in Valtech. So today I'm going to present you a topic about using the AI-based predictive caching, especially in the Sitecore JSS applications. And I want to just propose some actually insights on how we can actually approach this. So let's start. I start from discovering what is reactive caching, which is the traditional method of caching that we are using, right? So when we cache the data, right, let's say the most recently fetched data, right, and we cache in the database. This will only be effective, right, when the data access patterns are predictable. And if the data access patterns are like more random and non-predictable, then reactive caching won't be so effective. And we don't use the memories efficiently because we are putting all these large chunks of data in the memory that we may not really, most of them may not really be reused again. And the approach which I want to propose is the predictive caching. So predictive caching is about predicting what would be the next actually data access which would be requested based on the user patterns, for example, the user journeys in a website, right? And it is more effective when the data access patterns are not predictable because it can we can actually be more adaptive with predictive caching. And of course, if we can predict well, and we cache the data that are most probably going to be used, then we make actually much better efficient use of memory. So why using AI for predictive caching? First of all, it's like it can learn the complex user behavior, right? And it can be dynamic. So as the user behavior changes, our models also will learn and change. So we have adaptability to change. And it won't require human intervention because, for example, compared to the approaches like rule-based caching, which you can actually set some rules based on prediction, but then human intervention is required, right, to set the rules and change them. And the accuracy, so we get actually better, more accurate caching. So how I want to approach this, the steps is, well, first we need to collect the user behavior data, which actually I can explain in the next slide, which what are the possible sources. We need to prepare the data, clean the data, and then we can train an AI model, and we can actually predict the next request by giving the current context and the current request, right? And we integrate it to Sitecore, and of course the model can be continuously updated and learned, so it works based on the dynamic patterns of traffic which is changing on the site. It can actually adapt. So the sources of data are whatever source, any source that stores some data user behavior. For example, it could be server logs, it could be Google Analytics, or Sitecore CDP, CRM systems which hold a lot of information about users, and tracking tools, right? So any source which actually stores something about the user's actions on the website can be used, and we can actually combine multiple sources together to get even better results. So then we need to build and train a model, right? But how are we going to approach that? So the first option would be that we build our own model, right? We create and train our model, which of course requires data science expertise. And the model might be actually so sophisticated to design an efficient model, right? And we need time and money to train and prepare the model before usage. But we can do it, for example, for TensorFlow. As you can see, there is actually one model is a very simple one, but we probably need actually more sophisticated models for production environment for the actual use. So the second option is to reuse an existing model, right? So if you don't have the expertise, for the data science expertise, then still you can use the existing models like the services which are provided by OpenAI, which I'll actually explain further a bit. You can save the time actually for training the model, and the model is effective. And these models already have a lot of data about from the internet, and you can actually utilize that. So you can understand actually the URLs, and with some training, they can act very efficiently. So OpenAI text completion API is one of the actually existing ones which we can use it for this purpose, and I will explain how to just train and use this model. It comes from a lot of tools like CLIs and the libraries, which can help developers to just develop the applications, and it allows you to fine-tune your model. So in addition to the existing models, which you can readily use, you can also create a custom model based on an existing model and train it, right? And so we can actually use it to predict the like next URLs. And so the way it works with that, we are providing, so the way we want to design it, we are providing the current URL that user is visiting and probably some context as a feature, and the output would be the next URL, right? So first of all, you need to collect all your data, and before training the OpenAI model, you have to make a JSON-L format. With actually this would be like this example. So you create examples, prompt and completion, and provide it actually in this format. So with all these examples, you can put it in one JSON L file, or you can have multiple files, and then we can actually use the OpenAI CLI to train it using this model. So there are multiple models in the OpenAI text compilation which we can reuse. So DaVinci is probably the most capable, right? But it's also slower and it's most costly. So I've actually tried with Ada also. So for our purpose, Ada might be actually the best possible model because it's quite cheap. It's much cheaper than the actually more existing models, and it's fast. And that's what we need to reduce the latency. So we need to get the responses as fast as possible. And then, as you can see, we can just fine-tune the model, right? The JSON-L file, which we prepared actually in the previous steps. We can use it and use the OpenAI API to just create a custom model. So once we fine tune the model, it will create our custom model for us. And then later on, you can also retrain the model and keep that model as much as you need. And then you can actually call the OpenAI API, and you can specify the model which you are actually calling. So so you can use your custom model. So the model actually to work well, we need some adjustment and enhancements. First of all, validation. So for your data source, probably it's best to split it into two actually parts. Use some part of the data for training and another part for validation, right? That increase the accuracy of the results. And there are some hyperparameters which, when calling the OpenAI API, you can actually use them, adjust them, and you can adjust them and do like play with them a bit to see what would give you actually the best results, the faster and also the most precise. And then you can fine tune your model again. Okay, so now we want to bring this, we created our custom model. We want to bring this actually to our Sitecore application. So we just create an API, right, to call our model, the custom one that you created. The the name of the model would be actually something specific. You can also change and adjust the model name. And the hyperparameters, which actually was discussed, you can pass them. And then we can actually use this API reach. So to get the next URL, of course, this is just an example for just describing the concept, right? So probably the actual code for production would be actually more detailed and more complicated than this, but just want to show you the concept. So when we want to get the next URL, right, we just use OpenAI to get the predicted next URLs, and then as actually that URL is being processed, the next possible URLs also will be asynchronously processed to collect the data. For example, in the get server-side props. And so it won't block the current request processing because it does it asynchronously, right? But then for the next actual request, if the prediction is right, then the data is already loaded. And there are a lot of benefits for this to, of course, improve the site loading time and performance, and reduce the load on the server, as a lot of the requests will be handled actually from the cached data, and optimize sales and marketing because your response time would be much faster and the website works better, right? And then you can have personalization also, but with it actually improve performance, right? Because no matter if you need to have do the server start rendering and you need to do something custom pages, right, which cannot be converted to static, you can still gain some performance using this. And the challenges for this, of course, one is the cost, right? So the cost of open API implementation and collecting the data, preparing the data and training, right? And also the latency. So the latency must be managed, right? So if the latency of the request from the OpenAI is actually too high, right, then we will, I mean, the benefit of this approach will be eliminated. And could be complex, the complexity of solutions, deployment solutions, as the data might come from the cache with the different logic that could be difficult to debug, and the data privacy concerns because of the usage of the user data and how much data you can use, and that could actually pose some challenges. So thank you. That's the end of my presentation. I think we might have a little bit few minutes. If you have any questions, please. No, I will be happy to.
Thank you, Ehsan. Yeah, really interesting. It's AI related stuff is always trending nowadays. So yeah, really good approach for caching and improving performance. I don't see any question yet, but again, if anybody has any question, you know how to reach out to Ehsan. We'll come back. So hope the time was enough to at least grab a coffee. So we're gonna continue with the next session. Jeroen is going to present going to the other side with headless. So Jeroen, if you're ready, please feel free.
Yes, thank you, Miguel. So my presentation is titled Going to the Other Side, and I will explain why I come to this title. But first, I'm Jeroen Speldekamp. I'm a solution architect at UXB, and over 10 years experience in web development. I'm 10 times Sitecore MVP, and I hope with this presentation I inspire at least one developer to also take on the journey to the other side to do something with headless. And if there are any questions that you say, oh, I'm not there to ask in the chat, just send me an email or contact me on LinkedIn. I will respond to that. I work for a company called UXB. It's based in Delft, in the Netherlands. We are fully focused Sitecore. So we do only Sitecore projects right now. We have 3 Sitecore MVPs, 2 technical and 1 strategy. and we are specialized in the more complex implementations like commerce and portals. So starting my presentation, this is kind of brain dump looking at my history of programming. So I started out with machine language, and I learned to program in Pascal. So I switched. I had to switch over. After that, I switched to C and C++. And after that, I went to DBase. And after that, I started in Clipper and did a lot of applications in Clipper. And then I had to choose to go to Java or Delphi, and I choose Delphi, and I built a lot of applications in it. And in that time, also web development came on, and I did some side steps in Cold Fusion for the people that know what it is, and ASP. And then I moved over to C#, and in version 5.2, I switched over to Sitecore, and I did a lot of projects in Sitecore, also React projects, and lately also programmed in Terraform, because we have customers that are using Sitecore Managed Cloud on containers. So now I'm here, and I give it the name going to the other side, but it's more like peeking on the other side. I'm not moving totally over. And I come to this conclusion because of I went to the Chicago, to the Sitecore Symposium, and also I went to the SUGCon in Malaga, Spain. And I had some tasks for me, and one of them was, because we are working on headless, found out and sharing knowledge. And in Chicago, I didn't find anything except that the sessions were, Next.js was great, you have to use it, but not in-depth situations or knowledge exchange. In Malaga, there were sessions, and there were good sessions, but those sessions are just sessions based on documentation of Sitecore. So I already did it, or you can do it just going to the website of Sitecore. But what I figured out was that there are two camps on that symposium, and one camp were developers that wanted to stay on .NET Core, and other saying, "Are we moving over to Next.js or other headless systems?" Out of the box, Sitecore just present Next.js. If you do something else, you have to create your own rendering host. So by Uxbee, we has chosen for to go with Next.js. And at an early stage, we choose that path. This is a drawing from Sitecore. I made this, but it's a drawing of an architecture. And if you ask somebody what's in the red square, everybody knows. But if you ask what's in the green in the headless, they say, yeah, it's the headless application. But what I wanted to know, what's in there, because I always want to make maintainable code. So not code that you write and the project is over and you say goodbye. We at Uxbee want to have a long relationship with our customers, so we want to make maintainable code. So if we have to change something after a while, we want to easily pick up the project, run the project, program it, and do stuff. And that's with front end. Yeah, that's a challenge. So I couldn't find any answers. So I just created this journey. So I don't say I have the Holy Grail, I know everything. I want to take you on a journey that I and Uxbee took to go and implement a maintainable environment of headless with Sitecore. So right now, and this presentation was an interactive presentation. That's not possible in this setting, but there are 3 pillars we are working on. So we have headless architecture, design system, and environment. So I will go into the headless architecture, but I want to mention the design system. It's very important to have a good design system. So I will do another, I think, YouTube movie of a clip about it, explaining what it is and how you can set it up. It's totally worth it to have a good design system, and also your environment. So in the previous session, you saw what to do when you want to host it on AKS, but I want to talk about when you want to start up your development environment with just a click and not 2 days work. So I will go into the headless architecture. And before I do that, a little bit of technology, just to be sure that everybody knows what I'm talking about. So here you see an just out of the box created Next.js application. So nothing Sitecore, it's just an hello world. And I want to point out 3 files that I think are important, and I mentioned them throughout the whole presentation. So the first one is the package.json file. And after this, I just call it the package file. And the package.json file is, you can see it like, first I thought it's like when you're in C#, it's the project file. But a better description is when you're creating NuGet packages with C#, you also have a kind of NuGet file where you put stuff in saying, oh, those files are needed, this is the version, and whatever. Just see it as this. So if you want to run something on Node.js, you have to create a package. So some packages are runnable, you can run them, you can see a website like this one, but some packages are just code containers. Let's say it, name it that way. So what's this in the file? So first you have a kind of info block, and with this out of the box, it's very small, but you can imagine when you have a package that you have your Git repository URL, your licensing stuff in it. But for now, this is the part. You have your script part, so you can run scripts, and you have your dependencies. And as you can see here, I'm zooming a little bit in and a little bit side information. You can see here, I will go to Next.js. It's version 13.4.4. And you can see here, there aren't any prefixes. There are 2 prefixes that you have to know about. This one, yeah, I don't know the English word for it, but what that means is when you have, you can read it like this. So 13 is static, but the minor versions are not that important, but you can run also the version 0.5. And that's a very important thing. There's also another sign that you can prefix it with, and then it will be this. And then, yeah, you always have the latest version, or the version isn't that important. So in other files, you can see those prefixes, so you know what they mean. So this is for the package file. And when you have a folder with a package file and you run npm install, all the dependencies will be installed, and you will be having a node module folder. And the node module folder is standard about 2 gigabytes big. So that's a thing. And I come to that later. And when you run the npm install, you also create the next file, and that's the package log file. And in this presentation, I will refer to log file, and that's the Google map of your package. So, for instance, zoom in. When you look here, you say, okay, I'm here in the Node modules folder on the Babel runtime. I need this version. If it's not there, I will download it from this URL. I can check if it's the correct one with the integrity. And you can see here, and that is very important, it's depending on this. So the runtime is depending on the regenerator runtime. And you can see here that's needed that version, and you see the prefix. So what happened is, if the runtime is installed, also the regeneration runtime will be installed in your Node modules folder. And if the regenerator runtime also have dependencies, it will be also installed. So that's why you can imagine that the folder can be very big in size. And that's very important because this file is needed to create a build. So when you build something, the build is looking at this file. So don't forget to check in this file in your source control. Another file that's important, it's because we are using Next.js, or we're going over to Next.js, is the next.config.js file, and I will be referring it to the next config file, Next.js config file, and this is an empty one. So it's an empty object, and you can put between the square brackets all kinds of neaty things. So and I will show you later on. But for now, because this is out of the box, it's empty, and because it's an Hello World application. So this is the kind of pre-information you need to have if you want to do something with front end and Next.js or React. So every folder that we want to do something with needs a package file, and from that package file, it will be creating a log file. And because of that, every folder containing a package file will also containing a Node.js modules file. So you can imagine if you have multiple folders, that will take some disk size. Okay. We are switching over. When I think everybody has done it, just creating a Sitecore Next.js application. That's the first one. And normally, if you do this command, then yeah, you probably want to start disconnected, but that's not the best solution. But for this this presentation, it doesn't matter much because it's more the architecture that I want to talk about. The lower one here is when you want to install a total environment, including a development environment, including all Docker, running on Docker. So also the rendering host is running in a Docker container. Then you have to do the the bottom one. I'm focusing on the top one. So when you're type that in and you give it an enter, then you have to fill in some answers. And if you do everything correct, it will be installing a lot of npm packages. And after a while, you got it's finished, and you got 17 vulnerabilities, 9 moderated, 5 high, and 3 critical. So I can do an whole session about it, but it's very hard to solve that part. But that's the only thing I didn't have an answer for. But we have finished, and when you look at your Visual Code, then you see here your Sitecore project. And then the question is, so everything stops here. So you have your project, go and build. And that's very strange for me because maybe I have 2 applications. We have a corporate website, we have a portal, two portals. We have our design system, and maybe we want to share something between those. And when you are looking for answers, many, let's say, front-enders say, just copy the code. It's much easier. Just copy the code. So, but that's not an option, or was not an option for me. I say, don't want duplicate code or whatsoever. I want to have, a good architecture and maintainable code. So how can we do that? So for example, we have just one project. We call it Going to the Other Side, GTTOS, and that has two applications, app 1, app 2, and we have three libraries, lib 1, 2, and 3. And we want to share libraries. What normally it says, just copy the libraries in your application, the code, copy it in. And of course, that's very quick, but it's not maintainable. So what you can do, and I came out and you see it much often right now. They call it a mono repo, and the definition of a mono repo is a single repository containing multiple distinct projects with well-defined relationships. And when I saw that, I just must think about Helix and the Helix principles. So that's also, you have projects, you have features, you have foundation, you have your project, and you have well-defined relationships between them. So that would be nice. So for example, if you're looking now at the situation, I just have Storybook, and Storybook is my design system. I have a library UI core containing core components. I have a portal, I have an util library, and I have a Storybook Sitecore library, and that's needed in Storybook because in our design system we also build Sitecore components, and we can build Sitecore components without Sitecore, just using that library and mocking Sitecore. As you can see, I just forgot something because the Sitecore Storybook library also use the utils, this to make it totally complete. This is the references, and it would be nice if we can do this. So a mono repo, I thought about it. If we have you create a solution, and you have your foundation projects, you have your feature projects and your projects, and that's also in one repository. So already it's a kind of mono repo. So we did it already. But the opposite of a mono repo is a poly repo. So a poly repo is the current standard way of developing applications. A repo for each team, application, or project, and it's common that each repo has its only a single build artifact and a simple build pipeline, as you can see in the drawing below. So if you, but for our situation, for headless, that's not a good idea. For instance, we are working here on the application, and then in the library we are missing something. So then you have to close everything in your application, go over to the repo of the lib1, pull the development, create a feature branch, do your stuff, commit everything, create a pull request, then start the build pipeline with a new version. And then when it's finished, we have to put in the new version, and we have to update our new package or whatever. So that's not really a good situation to work with. Why I'm showing this is because of we are at UXB, we are going steps further. So we have mono repos in projects, but in the mono repos we create libraries that now are finished and can be in a poly repo. So for instance, as you can see here, we have 4 mono repos, but we already created a library for the security headers, for basic UI components, our storybook mock components and external libraries. And then that's a library for when you want to use Google Tag Manager or Cookie Bot. That's stuff that you don't want to invent or build every time. So that's we started out in a mono repo, but it's finished. It's not changing much anymore, and it's moved over to the poly, and we are using that in a private right now in private npm package repository, and we're looking of maybe that we put something on the marketplace of Sitecore for the headless part. So now we're going back to a mono repo because that's the thing I want to talk about. So when you're on the mono repo, how can we accomplish that? So without doing a lot of manual work. So when you look at npm, and then I have to also mention we choose to use npm, but there are also other that you can use, source yarn, pnpn, and maybe more. Choose one and stick with it. You can't use multiple. So you cannot say I'm using npm and my colleague is using yarn. That's not possible because yarn has a different log file. So then you have 2 log files. So that's not an option. So we're using npm. I'm not saying you have to use npm. Use what you like and stick with it. And we right now using npm, and yeah, it's doing everything we want. So that's a side note. So what we do is we have a root folder calling GTTOS. And when you look in the documentation of npm, you can create workspaces. And that's the part I want to talk about because that's very interesting. And what happened is in the documentation of workspaces, they say you have a folder apps containing, of course, applications. And you have a folder called packages containing packages. So packages aren't runnable packages, and in apps you can run. That's the difference. But you're free to choose what you will call it. So you can also create a folder project and feature and foundation. And I have to, we have a project that we're using it and it works great because you're familiar with it and you can use it, but it's not necessary. You can also use apps and packages or whatever you want, but don't change it. If you choose it, don't change it halfway, then you have a problem. So what we want to do is create for the green and the red workspaces. And how do we do that? It's very important, very simple. What you do on high level, so in your root folder of your mono repo, you create a new package file. And that package file, it's much smaller. You give it a name, you can give it a description and whatever. But the most important thing is this part you put in workspaces. So, and you can do it on different. You can say I have apps / storybook. The next one apps / corporate, and so on and so on. But then you have to do it for every package. But you can also use asterisks. So what this means, and that's very important, is that for the folders apps and packages, all the folders beneath that folder that contains a package file will be a workspace. If you have a folder that doesn't have a package file, it's not a workspace. It's just ignored. So that's important. So you have your script files and your dev dependencies. There aren't. You have two options. You have dev dependencies and dependencies. Dependencies are for runtime if you're running your application, and dev is for development. So you can see here you're on root level. It's not an application. It's for your workspaces. So we only have dev dependencies. And the nice thing is, and that's really nice, when you're running npm install on root level, then there will be a package log file created. But all the other log files in your package folders will be removed. So there's just in a mono repo with workspaces, there's just one package log file containing everything, the whole shebang. Also important, every package folder under or workspace, every workspace under the root folder as just only have the package file. The log file is gone, but the node module folder is there present, but almost empty. It contains a few packages. All the packages are moved to the root folder node module folder. So you're sharing, if you have a component, you're sharing that component. It's not copied to every workspace. So it saves a lot of disk space, really. So how it works. For instance, for example, we have Storybook. This is our design system, and the design system will be using our UI core library. And what happened is, if you are doing something, you will go up to the root of your mono repo of your folder structure, and you will be searching for that module. And if you're looking in the node module folder, you find your UI core folder. And that's because you did an npm install. So that's out of the box, it's there, and you can see all the other stuff, workspaces are also there. But you also see that it's a different folder. It's not a real folder. It's and they call it a symlink. And it's very used in Linux environments, and it's also in Windows, but it's not that familiar to everyone. And what does that mean? Because that's an important thing, and I hope I can explain it. When you look here, we are in the mono repo root folder, and we are looking in the node modules folder, and we are looking here at the UI core folder. When I'm looking in that folder, it's not a folder, it's a link to this folder in the mono repo packages UI core. So we have two locations pointing to the same files. And that's an important thing. And that's also a thing that I'm not going to explain, but when you're running in Docker, your rendering host and using symlinks, that's not going to work because Windows is not Windows on Docker is not familiar with that. So we have solutions for it. You can solve that part, but that's another session. So that's important. So I did the install, npm install, and all my workspaces are like Node.js packages. And what does that mean? When I look in the package file of my Storybook, and I say I want to use the UI core, the only thing I have to do is to just say UI core and then put in an asterisk, because a version is very strange because it's a mono repo. It's just pointing to another folder. It's not that a version related. So that's why you put in an asterisk, and it just take the code out that symlink folder. And what does that mean here? How do we use it? When you use here in Storybook, we create a story and we want to use a demo button out of the UI core library. So we say, okay, I want to import the demo button from the UI, so the UI core from demo, and I want to use the demo button. So that's very, I think, maintainable. Do you need it? Can you do it in a different way? Yes, you can do it on a different way, because you can also say dot dot forward slash dot dot forward slash dot dot forward slash. Then I'm on the root level saying packages UI core demo, and you know what I mean. So that can also be placed here, and that will work also. But I think it's not maintainable. I've just one rule. You can use that part if the file is generated, because you can then generate the file again, and then your path is correct. Because where it goes wrong, and we had that, is when the UI core, when you say, okay, it's finished and we want to make a NuGet package from it, then it will be removed out of your mono repo. And maybe UI core is not the best example, but just for example. And the only thing you have to do here is to fill in here your version. And everything works. If you have the path, you have to go through all the files and do all your testing again. So for maintainability, workspaces are great. Is this the end? Are we done? The only thing we had was we can run in development. That's no problem. But I was missing I call it the glue between the workspaces, because now we have one big solution. One big log file. How can we create stuff? How we can build it? And that's where we choose for Turbo Repo, and that's from Vercel. And Turbo Repo, as it already stated, is a high-performance build system for JavaScript and TypeScript code bases. Hey, we are doing TypeScript, so and it's high performance. And what does it do? So that's the thing I will explain now. You have to install it. And then if you have installed it, npm install turbo, that's the only thing that you can do. You can install it globally or as a development environment, dependency, sorry. And then you do a turbo init. And with the turbo init, there will be a turbo JSON file created. And I just put in a small one, because right now, I think I'm just scratching the surface of what I can do with Turbo, because it's a lot. But I just want to show you what you can do, and there's a lot more. So I only want to show here the pipeline. So you have pipelines, and you can see we have a build pipeline, we have a lint and format, check types, def, clean all, and storybook. So I'm not going to explain all the properties that you can put in a pipeline. I'm only discussing the pipeline. What does a pipeline do? So for instance, when I'm typing in turbo build in the command line, then turbo, first it will be looking for the turbo JSON file. So you have to run this command in the root of your mono repo and not in a folder beneath it, because then you get an error. It will be opening this file and searching for the pipeline build. So it has this pipeline build, and it can do something with the variables that you put in. And then it will go look for every folder in the mono repo and search for the package file. And if the package file has a script called build, it will be running that build. So when you have a build and you have multiple workspaces that can build, all the workspaces will be built. And you can do it serial, so after each other or parallel, or you can do a lot of it. It's but also when you want to run, you want to clean, you want to start Storybook, it's also possible. So you don't need to do npm run or whatever you're using, just turbo. There's another thing that's very great for Vercel is caching. So this is me. I'm not good at drawing, but this is my colleague. So we have, let's say, 2 applications in a monorepo and 2 libraries. If I do a build, all the workspaces will be built. That's what I already sent. So, and when I build it locally, it will be saving the cache. So it saves something on my disk, all the stuff that is built. How, I don't know, but it's cached. So the first build could be taking 10 seconds to build. When directly after that I do the same build again, it will be 1 second or maybe less because it's already cached. So that's very nice if you're working on stuff. So if you have it in place, you can locally run it, just run it. The first time it's slow. The second time it's only building the stuff that's changed. So that's very nice. But if you have a very large monorepo, there's also a possibility to share the cache of the build. So when I already build it, then my colleague doesn't have to build it. So when you change something here and I build every other part, it's just getting the parts from the cache. So that's very, very fast. The only downside is it costs money. So if you use it locally, you just can use it out of the box. If you want to have a shared cache, you have to log into Vercel and connect and share the cache. So that's the only part. But if you have and I think it's only interesting if you have a very large mono repo that will take, let's say, 15 minutes to build, then it's very interesting to share the cache because that's will save some time. So that's one of the nice things. It's blazing fast. The other thing is when you and I'm going to my again back to my mono repo, and when you want to build it for production, what happened is we only have one log file, and yeah, that log file contains everything. So the whole stuff. So I have an sorry, this one, the whole stuff. So when, for example, it's 200 MBs for the artifact, if you build everything, but if I only want to use app 1 or app 2, and it only use the library 2, maybe it's 50 MBs. I still have just one log file, so I have to build everything. So that's yeah, you can say, oh, that's no problem, but I think you have code there that doesn't do anything. So when you're running your app 2, you also have code for app 1, but it's not started, it's not doing nothing. So monorepo has there a solution, and it's called prune. So it's not prune as by Docker deleting stuff. It's pruning your log file. So what happened is you can say, okay, I want to build Storybook. and I will prune Storybook. And what happened is there will be a new created log file containing only your map of your Storybook with your references. So that's what I showed you here. So when I run prune on the app2, you see the log file will be much smaller, and the output will also be much smaller. And that's very interesting part, because if you have a large, it's possible you have a large mono repo, you just want to have on the runtime only the code that's needed and not the code that's not needed. So that's a very interesting thing that you have on the mono the turbo repo. So that's the part what's I think very interesting. Are we done? So just a look back. So we started out with just one application of Sitecore where you can do everything. And I have to confess, I did some React applications and not with TypeScript, just with JavaScript, and put everything in, because we started, JSS was just released, and was the way to go. And all the front enders just put it in. So that was the way to go, but maintainability was not that good. So from there, we created workspaces so we can separate our code. So we have some stuff for sending stuff to the application inside, or we have external libraries, just lib files, but also our components, or Sitecore components. You can put it in libraries, and you can share them between your applications. So core, you share it between all web applications. And if you have some specific commerce, you put it in another, and you can share it. The only thing is that we are building in TypeScript. So what happened is that when you're building, and I'm going back, you're building. So we have let's say, for instance, we have a new log file, and the log file says, okay, app2, I also need the utils. So you're running the applications. This is a Next.js application, and say, I want to build. What happened is you have compilers, and a compiler has output an executable, but you also have transpilers. And transpilers are putting code from one code to another code. So from TypeScript, what we're using, to JavaScript. So that's done in the Next.js application, because there we installed stuff and settings for TypeScript. But we also have a connection through the top node module folder with a symlink to our util folder, for example. But there we only have TypeScript files. So the error that you can get is interface. I don't know what it is. So we are using Webpack to bundle everything, or let's say build. Interface is something you use in TypeScript, but not in JavaScript. It's not there. So you get strange errors saying and that's was a tricky part before Next.js 13, because then you had to install kind of third-party modules and do some stuff. But from version 13, it's implemented in Next.js. So that's very nice. So what you have to do, and now you can see here, we are filling our setting Next.js setting file. So the only thing you have to do is fill it in here, say transpile packages, and create an array, and just say I want to transpile the UI core and the Storybook Sitecore, because that's what I'm using. And what happened is transpile, so the JavaScript will be the TypeScript will be transpiled to JavaScript code, and then you have your JavaScript code in your application, and yeah, everything works fine. So that's an important step to do, because otherwise, if you're using TypeScript, that's the step to take. If you're not using TypeScript but JavaScript, then you can just then you don't need to transpile. So that's the step. So what we have is we have workspaces. Therefore, we can, when we build, we can easily get to our libraries. And because we're using TypeScript, we have to transpile the TypeScript files when we are building. And then we have our output. Okay, we are using TypeScript. It's not necessary, but yeah, it's type safe. So let's say at compile time, you're seeing errors. The only thing I want to mention is if you're using TypeScript like npm, use it everywhere. Don't mix it up with JavaScript. So what happens sometimes is that you have examples, they are in JavaScript, then you have to convert them to TypeScript. Don't mix them together, because then yeah, you get errors, strange errors. And also what I found out is that in the community of the front enders, they are stepping a little bit away from TypeScript. Say, don't use TypeScript. It's a little bit strange. You have a language to generate a language. So that's the discussion. But I work for a while now with TypeScript, and yeah, I like it very much. So, but it's not necessary. If you want to use JavaScript in Next.js, it's also working fine. So are we there? We have just one challenge, and I'm looking at my time, so I'm thinking I will stay in my time. So that's also nice. So just one challenge we have to do, and that's, for example, we have a Next.js application corporate website that are using also the UI core, and we have our component is in our UI core, so we have transpile. Everything is there, but when we place our component on our page and we see the page, we get this error. And the error is a JSS component is missing React implementation. But if you're looking in your library, there isn't, the implementation is there. So that's strange, but I can explain what happened. So when you're defining your rendering, and it's a JSON rendering, I think they call, then you have to must fill in your name, your component name, and just ignore the number, because I added the number to get that error, but it's composite component. It's a demo component I created to show how something works, just for demo purposes. But and how it works is this: so you put in this name, and then when you look into the output of your layout surface, it says in the headless placeholder, I want you to place a component with the name composite component 1, and 1 doesn't exist. So that's so what happened in the front end, in the front end libraries of Sitecore, it's gonna search for that component, but it doesn't find that component. How is it possible? No, it's not rocket science. So when you are in your Next.js Sitecore application, there's a folder called scripts. And in that folder scripts, there's a script called generate component factory. And when you look in that file here, you can see that it's only looking out of the box, only looking in the folder source components. And that's the component folder in my Next.js Sitecore application, but not in my library. So that's the reason why. And what happened is it's only looking in this file if there is files added or deleted. And when that's the case, it will be creating in the folder temp a new file component factory TS. And if you look in that folder, you can see here, those are the out-of-the-box components of the SXA headless. So I'm missing my component. And what happened is there is an import. So, and for example, if you say, okay, I'm from the source components column splitter, I want to import this class component. And then in the generated file, there is a mapping created. And you say, okay, if you're saying with this string column splitter, then I give you back the class that's the column splitter. So that's how Sitecore knows how and what components to do. If it's not in this, list, of course, you get the orange error. How do you can solve this problem? So we are, and that's also what I'm saying right now. We are we changed this this file, generate component file, and add another location to watch. So right now we have 2 locations to watch, and that works fine, totally fine. And then what you have here, you have the ./././UI and so on. But that's not a problem because it's a generated file. So every change, it will be generated again. With every build, it will be generated again. So it's always up to date. That's but we are also working on a better solution, and that's like the transpile that you can in your Next.js settings file, you can give path to scan components, and we put that in. That's now in beta testing, but that's a solution. So, and and how it started. That's also how does that work when you're developing. So this, what you now see is from within the Sitecore Sitecore package file from our Sitecore project, and then the script section, and that's out of the box. And what happened is when we start up, we want to connect to Sitecore, so we started connected. This is an CLI run all, and in serial, so it will start Bootstrap, not the Bootstrap framework, but to bootstrap things. And you can see here, this is what triggered. And then parallel, it will be starting the next dev and the start watch component. So the next dev is this one, it will be starting, and the start watch component. And then you can see here that we're starting that script file with the tag watch, and that means it just don't generate once the file and stop. It just stays in memory and watching the folders, and if something changed, it will be regenerating the file. So a small recap is a small recap. Come on, yeah, a small recap. So from just one big monolith application, we created workspaces that we can share. We created a build system that can build parts of it with Prune. It's quick, it's clean, it's maintainable, and with a small change in your scripts, we can also register the components in Sitecore, and therefore we can use them from libraries and share them with each other. So that's the architecture that we are working on right now, still working on. That was my journey on the architecture. And I hope I can inspire somebody to say, okay, that's interesting. I will also look into it. And if you have any questions, you can ask him now. If later on, just send me an email and we can do a session, or just I can answer your questions. Thank you.
Thank you very much, Jeroen. I think that was a really interesting session, especially for backend developers without experience with headless. And I think that's really interesting for them to start digging into this new world of kind of front-end development as well. So there's no questions as far as I can see, but again, you know where to find him for any questions related to this topic. So thanks again.
Okay, so that's great. A quick introduction about myself. I am Vinay Jadav. I am a senior Sitecore developer here at Valtech France. I have around 6 years of experience working on various versions of Sitecore. I am a Sitecore MVP technology in 2023. I blog regularly on vinayjadav.com. These are my LinkedIn and Twitter URLs if you want to reach out to me. So the agenda for today will be, I'll be introducing you to Sentry. I'll be showing some key features that Sentry has to offer. I'll be showing how you can integrate Sitecore JSS with Sentry. And we'll have a difference between Sentry and Azure Application Insights. And I'll also show a short demo where I'll show you what the issues and how you can track performance with Sentry. So Sentry.io is what is offering this product. Sentry is actually a developer-first error tracking and performance monitoring platform. So on Sentry, you can, as developers, you can see key stack traces and what errors and where it happens, everything. And it also offers you around SDKs for around 108 platforms. So if you are developing on a particular platform, there's a good chance that Sentry offers an SDK. So the key features of SDK is that, as I said, it offers you SDKs for around 108 platforms. So, and usually it has a wizard to integrate your solution with Sentry. So it's very quick and easy. It's also open source. You can use it to track both your backend and frontend. You can configure it for multiple environments and manage it on Sentry itself. You can host it on your own, or you can also use the cloud offering by Sentry.io, which is what is recommended. It's a SaaS offering. You get automatic email alerts for whenever you have issues in your solution. It also offers you major integrations with Slack, Teams, and it also integrates with your repos for GitHub, GitLab, Bitbucket, Jira, and also Azure DevOps, so you can track issues as well. You can also use webhooks if you have any custom actions that you want to integrate. So it offers you some basic subscriptions, style business subscriptions, and there is also a free tier for developers. So if you want to check around and how it is, you can always use the free tier. So how do we integrate Sitecore JSS with Sentry? Sentry does not really offer a specific integration for Sitecore JSS, but you can integrate with the front-end technology that you are using for JSS. So you can integrate it with Angular, React, or .NET Core, and also Next.js. So in my example here, I'll be showing you an integration of Sitecore JSS with Next.js. You will need some customization, but it's going to be very minimal. So how do you integrate Sitecore JSS with Sentry? As I said earlier, actually Sentry offers you an SDK. So you have a wizard which you can run with the CLI command that I have here. The wizard will prompt you to log into Sentry. It will install the SDK and create the necessary config files for you. It will also add an example page so that you can test if Sentry is working with your solution. The setup will automatically start catching errors in your application. It will start monitoring your performance. You can also manually capture errors, and if you want to push some specific breadcrumbs or data, you can also push that. You can also optionally use the Vercel integration to track your deployments if you're using Vercel. And then we have some differences here with the Sentry and Azure Application Insights, which we majorly use for a Sitecore solution. Sentry's logs are usually very data rich and they offer you device context. They'll give you what browser the user was using and what OS he was in, everything. Azure AI, on the other hand, actually only offers log entries and with limited customization possibility. Sentry logs will give you the browser data of the user. Azure AI usually gives you the geographic data of the user so you can see where the user is actually from. Sentry will give you the exact URL of where the error is occurred as part of its metadata. Azure AI doesn't offer it out of the box. Maybe you can use a customization to do so. Sentry primarily focuses on issues. The other logs are usually hidden behind. It doesn't really show it out of on your dashboard. Azure AI actually focuses equally on your logs and exceptions. So whatever is there to see in your application is always there on the dashboard. So Sentry is highly suitable for tracking your errors in the front end. That's what I conclude with. Azure AI, on the other hand, is really great for the backend application. So in a Sitecore setup, you would use Azure AI for your CM and CD, but for your RH, the rendering host, you'd probably better use something like Sentry. So I'd show you a quick demo of what we're talking about. So to begin with, I'd like to show the Sentry setup that I have. So as I said, Sentry will add you some config files and also the next config within the solution. It's quite simple. You don't really have to do anything. I have done some basic customization. Sentry, whatever that Sentry tracks is considered a transaction. What happens is because all the paths that for a Next.js solution in Sitecore JSS is going to be the path file that we have. Every request that comes will be shown as a transaction to the path file. So we don't want that. We want the URL of which was whatever's unique. So in our case, what I'm doing here is before we send a transaction, I am changing the transaction to the URL path name so that I can track precisely on what page this transaction is happening. So, and apart from this, in the path file, I'm also adding some context so that I can see whatever is happening. And you can also use various values here. I just have some values that could be relevant. So I'm seeing the rendering type, the database name, the site, the language, the path. So whatever is not there will be omitted when Sentry will record it. And sometimes the context can also be wrong. So this is just some basic data. Also, I have a middleware plugin for a normal mode here in the Sitecore JSS solution. So where I'm also adding the same things again, I'm adding the item path, the item ID, and I'm adding a breadcrumb for what the site name is. So whatever Sitecore has to offer at that time will be recorded by Sentry. So I'll also show you some of the issues that I've recorded. So I manually generated some errors possible. So in this case, when there was a field that was missing, I have this error. So it will exactly show on what file you have the error, on what line the error is. As you can see, it will show the browser that the user was using, the OS that the user had. You can see what URL it was happening, the user IP, every single thing that you, as a front-end developer, you would need to track what issue is happening. And it also offers a replay. In my case, because of is out of the box, it's configured to be masked so that you don't see the exact text that is there. You see a bunch of stars, but it's an exact replay of what the user is going through. Here you can see what the exception was, and the best part is you can see the console errors that the user was getting. So earlier, which was a console error, which was not supposed, which you wouldn't have been able to see that the user is getting, is now getting recorded in your logs. So this is one thing, and as you can see, I sent some context data, which will give you what database was using, if the user was in editing mode, what the language here is, and the path to the URL. So yeah, and of course, apart from this, you can always see the entire stack trace. So if you want something specific, if you want to see what it is, you can always see the stack trace. And also Sentry offers you to get a solution by AI, which you can pass your code, what the error is, and the AI will actually suggest you what the fix may be. So that's one great thing. So this is it, and you can also see the performance of all your pages here. As you can see, the transactions which are out of the box will only point to the file that you're pointing to, will also show you the URLs that the user is going to, and page by page you can see what the performance of the page is. You can see how much percentage, how it is, how much long it is good, and if you have any errors in the page at all, you get various logs and everything that you necessarily need. So yes, this is what you have on performance. And apart from this, there are also integrations for you. If you want to tag it with some specific, like if you want to have it in a repository, or if you want to track it on Jira, you can always create issues from here itself. You can also integrate it with Jira. Yeah, I think that's all is there for me to demo. And now I open it for questions if there are any.
Thanks, Vinay. I don't see any question, but I personally have one, if you don't mind. So at the beginning of the presentation, you mentioned that normally in a headless setup for Sitecore, you will have App Insight for CM and CD roles, and then only use Sentry.io for the rendering host. Let's say it's running in Next.js, but wouldn't it be better to also monitor the CD and CM roles with Sentry as well? So you get everything there. You can also maybe map all the different roles and stuff like that.
That's definitely true, Miguel. You can always, of course, go with both of them if you need to. I just, as someone who's used both of the tools, and I've used Azure Application Insights quite for a long time now, so it's easier for me to track if there are any logs that I want to see. With Sentry, it becomes a bit difficult because you can't exactly point to. It doesn't really log everything. You'll have to see it by transaction, which you can't query them. So that's a bit difficult. Yeah, I can always think of a setup where you have both. So the logs are sent to application insights, and you do the monitoring with Sentry. That's definitely possible.
Okay, thanks. Yeah, no questions. Only a comment saying, yeah, that's a great alternative to App Insights, which I agree, especially for Next.js. Okay, thank you, Vinay.
So can you confirm you are seeing my screen?
Yep, all good.
Okay, so let's get started. All right, so thank you for having me today. I'm going to speak about how Sitecore developers get this new trend called generative AI. So I'm going to explore the available tools for us. So our agenda for today is introduction to generative AI. What is it and why? The available tools for developers. Then how to get started. So we will learn how to use it in our Sitecore projects. And then prompt examples showing real use cases. And the last topic is about a comparative, giving my opinion. So just introducing myself for you. My name is Álvaro. I am a software engineer from Brazil. I work remotely for Sylog. About experience, I have more than 9 years of experience with .NET technologies, and I've been working with Sitecore since 2021. I took 2 certifications as well for Sitecore 9 and Sitecore 10, and at the bottom is my blog and my LinkedIn if you want to connect and share ideas. All right, so first of all, I would like to say that I am an enthusiast. I'm not an expert in artificial intelligence, so I would like to share my point of view as a user, as a developer. So starting with an introduction to the generative AI. So what is generative AI? So generative AI is a sub-area of artificial intelligence, which uses techniques such as neural networks and machine learning, and then it is able to create an algorithm. And this algorithm works like you feed it with a big amount of data, billions, trillions data, and then it is able to learn from those data, and then it is able to produce an output. So this output, this result can be an image, a code, a text, a video, and other things. So our focus today will be only code. But why should we use generative AI? So I bring 3 reasons. So the first one is to learn, because sometimes you don't know how to use something. So AI is here to help you. For example, you don't know how to use solid principle. So just give your code to the AI and then ask if possible to apply the solid principle. The second reason is the most obvious, to save time. So we can forget the manual work and focus on the solution. And the last one, I would say, is the insights. So sometimes you are starting a new project, a new task, and you don't know what is the best way to do it. So you can discuss it with the AI, showing your current solution and asking for more solutions. So it is a good tip to use an AI. All right, so what are the available tools for us as a developers? So there are many tools. I won't be able to cover everything, but I bring here 3 tools. The first one is ChatGPT. So ChatGPT is the most famous. So ChatGPT is created by OpenAI, which is basically a chatbot. So you can ask something and then this AI assistant will give you an answer. Then the second tool is the GitHub Copilot, which was created by Microsoft and GitHub. So GitHub Copilot is basically a plugin for IDEs. So you can use it in your favorite IDEs, such as Visual Studio or Visual Code. And the last tool I bring today is the Cursor. Cursor is an IDE, so it's not a chatbot, neither a plugin. It is a IDE. So it is basically the Visual Code with an AI assisted embedded. So my focus today will be only on ChatGPT and Cursor. But before, how to get started in those tools? and how we can use it in our Sitecore projects. Before, we need to understand what are the possibilities in the Sitecore, to be more specific, in the Sitecore XP. So I see at least 5 possibilities. The first is create views and controllers, then PowerShell scripts, enhancement and improvements, then fixing bugs, and then convert legacy codes. Okay, so how to use ChatGPT? So ChatGPT, I think it's the most straightforward. Just go to the OpenAI website, then log in or create a new account. Then just start typing. So you can type anything and the AI will try to give you an answer. For example, we can ask a code. So my question, create a code in HTML for my business website called Orange Restaurants. And then the AI answered me with a piece of code. So in my opinion, what are the pros and cons of the ChatGPT? So the pros, I think ChatGPT is fast and give you an accurate answer. It is free when demand is low, and easy to use, which means that you don't need to install anything. It's not required. And the cons, I would say that you needed to switch between ChatGPT and your code. So it is like a copy and paste process. So sometimes it is not so straightforward. And another cons is there's no special features for coding, because ChatGPT is something general. All right, and how about Cursor? So as I said earlier, Cursor is an IDE. So you need to install it going to the website of Cursor. So just go to the website, then download it, install it as a regular IDE, and then open the software. So when you open, you see probably this screen with the first option to open a folder. But before we get started using Cursor, we need to configure the license. So to use Cursor, we need a key. Cursor is free if you have an OpenAI key. So how to get your OpenAI key? Just go to the OpenAI websites and then go to the settings, and there is your key. So when you have your key, just go to the configure in the Cursor and put your key there, and then it will be free for your use. All right, so our key is configured, so we can start working. So I'm gonna open a project folder. In this case, I opened the Sitecore Habitat, and as you can see, there are 3 sections in Cursor. The first section at the left side is the file tree, so you can browse your files, open, close files. The main section is where you code, so you can see your code. And at the right section, there is a chat, so you can talk with the AI. And the interesting thing here is that you can ask anything, and the AI is able to understand the context, which means that you don't need to copy and paste your code into the chat text box. So when you ask something simple like explain this code to me, please, it will understand that you are asking something for the current opened file. So as you can see in red is the explanation. Also, there is another option where you can just press Ctrl K, and then it opens a prompt where you can type anything. For example, improve this code for me. And then the AI starts working on your code, reviewing, finding bugs. And in the end, there are options to accept or reject the suggestions of the AI. All right, so what are the pros and cons about Cursor? So I think the benefits are your code is integrated with the AI, so you don't need to switch between your browser and your code. It is free, and it is familiar. It is familiar for Visual Code users. So if you are used to Visual Code, it will be good for you. And the cons is it is free, while ChatGPT is free because your license key depends on the ChatGPT. And I think for some scenarios, the answers are shorter than ChatGPT. So for some scenarios, I don't like too much, and then I prefer ChatGPT. All right, so let's take a look at some prompt examples for Sitecore developers. I would like to say that there are at least 5 categories of prompts. So prompts are instructions or questions that we ask the AI assistant. So in this case, there are the category of creation, conversion, improvements, review, and explanation. So an example of conversion. So I know, and you know, that there are clients that is still running on old versions of Sitecore. Maybe they are migrating from old to new versions, but sometime you might face that they are using web forms. So web forms to MVC might be something you will face in your journey. So this is a prompt to convert web forms to MVC. It can be something like convert this ASCII code to CSHTML for Sitecore XP 10.2. So using ChatGPT, here is my question and my code. And as you can see, there are 3 placeholders. And I was curious if the ChatGPT should be able to convert. And here is the answer, and it worked. So as you can see, there are 3 placeholders, but now using the MVC statements. And in the end, there is a explanation about what was done. All right, so about about the first example of creating views and controllers. So views and controllers are something that we as a Sitecore developers face every day. So a good prompt could be something like write a Sitecore razor view, including examples of Sitecore HTML helpers. So now using Cursor. So here is my prompt on Cursor. And then here's the answer. Of course, this is just a basic structure. This is not all the code, but this is a good start point for you. So you can save time doing it. And a good tip here is if you need to create a controller, write a controller within the view. Why? Because in this way, the AI is able to understand the context of your view, and then it will create a better controller using the same names and the same patterns. So a prompt for controllers could be something like write a controller code for this view. Okay, so in the same file as my previous view, I just went to the line 33, and I pressed Ctrl K, and I asked it, write a controller code for this view. So here is my controller. Again, it's not the complete code. I needed to do a few changes, and I had to move this piece of code for another file for the properly folders for controllers. But this is a good insight to understand that when you create your controller within the view, you can help the AI to understand better the context. All right. Another example of creating PowerShell scripts. I know that many people don't like PowerShell or don't know PowerShell, but they need to do something with PowerShell scripts. So here is a prompt for creating PowerShells, and it can be something like write a PowerShell code for changing the display name of the first 10 items from a specific node. Ask the user to insert the node. After all, create a package of those items. As you can see, it is not a easy one. It's a complex prompt. I was using cursor. Here is my prompt, and then here is the answer of my question. So as you can see again, the AI was able to give me a proper code for PowerShell scripts. Okay, so an example of explanation. I think if you are a beginner, if you are starting with Sitecore, is something really good for you because you can understand Sitecore better. So if you are facing some hard code, some complex code, you can ask something like, explain this code for me, highlighting the Sitecore statements. So for example, I did it on cursor using the chat. And so here's a huge explanation about my question. And if you are not satisfied with the answer, then you can continue chatting and ask more things such as, what is the html.sitecore.field? Give me an example. And then, as you can see, in red is my second question and the second explanation. So I think it sometimes is good for you if you are trying to understand the code. Okay, so our last topic is a comparative between ChatGPT, Copilot, and Cursor. I know that I didn't talk about Copilot, but I think it's worth to compare with Copilot. Okay, and so in my table here, there are the three tools, and there are some columns that I think it is interesting to compare them. For example, about type. So ChatGPT, as I said, is a chatbot. Copilot is a plugin, and Cursor is an IDE. Integrated with code. ChatGPT is not integrated. Copilot and Cursor, they are. About features related to coding. So ChatGPT, there's no feature for coding, and Copilot, I didn't find anything, but Cursor has a few features such as linting, auto debugging, and rules. So as you can see, Cursor is focused on coding. About price. So price, ChatGPT is free when demand is low, but there is a plus plan where you pay 20 a month, and then you can use more resources. Copilot is free for only 30 days, then you need to pay 10 a month, and Cursor is free with OpenAI key. So my opinion about when to use ChatGPT, I recommend using if you are working remotely in the client server and you cannot install any software. So your best option here is ChatGPT. However, if you are working in our local machine, you can use both Copilot and Cursor. And so my score for then is the first place is for Cursor because this is an IDE. You can save time because you don't need to switch between browser and the IDE. Also, it is free, and also there are features focused on coding. The second place is for ChatGPT because ChatGPT is amazing. You can ask a lot of things, and then you get good answers. And the third place is for Copilot, because Copilot is not free for only 30 days, and there is no special features for coding. So guys, this is all for today. I hope that I have inspired you using these tools. And so I'm open for questions. Thank you so much.
Thanks a lot, Álvaro. Really interesting session. Again, there's not that much questions, but yeah, if you are watching this recording, you can also reach out to any of the speakers today with questions. And again, follow us on the YouTube channel, and also, subscribe to the YouTube channel. Also follow us on Twitter and LinkedIn, and keep stay tuned, because we are going to organize another event soon, as I mentioned before. So thanks a lot, everybody, for joining. Thanks to the speakers today. And yeah, have a great day.